Alright, so I'm going to talk through the 14.4 notes on arithmetic sequences. So this is a term that you haven't seen before, and I'm doing this a little differently. I'm using Notability to record, so let me know how it goes. Arithmetic sequence, or sometimes called arithmetic progression. That term arithmetic, I know if you read it you might say arithmetic, but it is actually arithmetic when we talk about it as an adjective. So these are any sort of sequences in which your common difference between two terms is constant. So what does that mean? It means that you are either adding or subtracting the same number each time. And that number that we add or subtract is called the common difference, and we use D to denote the common difference. So for example, in this first one, if I'm looking from 1 to 2, and then 2 to 3, and then 3 to 4, we're obviously adding 1 each time, so my common difference would be 1. For this one, I'm going from 3 to 7, 7 to 11, 11 to 15. I'm adding 4 each time, so common difference would be 4. Here, I'm going down and subtracting 5 each time, so my common difference would be negative 5. So it can either be positive or negative. It's positive when you're adding, it's negative when you're subtracting. So there's a way to develop, and you can see the patterns here. We want a formula for the nth term every single time. So it's always a plus something, right? Where a is your first term, and that's either plus 0 times that difference, or 1 of the differences, or 2 of the differences, or 3 of the differences, right? And so my a sub n, or my nth term, is just the first term plus, notice this number here is always 1 less than that, and that's n. This is my a sub n, or sorry, a sub 4, this is a sub 3, a sub 2, a sub 1. So notice that the coefficient of d is always 1 less than n, so it's just n minus 1 times d. So this is what we call an explicit formula for the nth term of an arithmetic sequence. You can see that below in the box. You don't have to memorize it because it'll be there, and you'll just need to know where to get it. So we're going to use that formula to determine the 100th term of the arithmetic sequence. I'm just going to rewrite the formula. A sub n equals a plus n minus 1 times d. All right, so now let's define all our variables. So in this case, I've got the 100th term, so that 100 is going to be n. Over here, we've got the first term, that's a, and then notice I'm going up by 3 each time, so d equals 3. So we've got a equals 7, d equals 3, and n equals 100, and we just plug them into the formula. So this is going to give us the 100th term, a sub 100, equals the first term, 7, plus n was 100, minus 1, times that common difference of 3. And then you just work this out and get, use your calculators, that the 100th term, a sub 100, the 100th term in that sequence would be 304. All right, now this next one, a little different. I'm going to show you 2 different ways to do it. So let's start with the information we're given. The second term is negative 2, so that means a sub 2 is negative 2. And the 8th term is 40, so a sub 8 is 40. So one way you can do this is you could actually use the formula that we just learned up there, right? So I'm going to say, okay, this is a sub 2. I don't know what a is, but I know that n is 2, so 2 minus 1, and then d, I don't know either. Similarly with this one, I don't know a, but I know n for this one is 8, and I don't know d. So now I'm going to just simplify. This is a system of equations with 2 equations, 2 unknowns, so I can just simplify that. 40, 8 minus 1 is 70, and then I can solve this system. I'm going to go ahead and just do subtraction so that my a's cancel. So I get negative 42 equals negative 60, and d equals 7. So I know the common difference. When I take that common difference, I can plug it back in to either equation, or I could plug it back in here even. That's probably easier. And I would get negative 2 equals a plus 7. And so a would just be -9. So when it says in the problem to determine the arithmetic sequence, what they want you to do there is list out. So list out at least the first few of the sequence. So I'm going to start with -9, and then if my difference is 7, I'm just going to add 7 each time, right? And then I just do ... and there's my arithmetic sequence. So that's the one way you can just write your arithmetic sequence. That would be my final answer. Okay, that's the one way to do it if you're like going through step by step, finding your system and your equations and using the formula. The other way to do this would be to kind of look at it in a little step back a little bit and get it a different viewpoint. What do I mean? So if I list out this sequence, I don't know the first term, but I know the second term is -2, 4, 5, 6, 7, 8, and I know the 8th term is 40. So if I think about this, that's a distance of 1, 2, 3, 4, 5, 6. Okay, how did I get that number 6? All I did was subtract second term and 8th term, right? So I literally did 8 minus 2. That gave me 6. So it's 6 terms that I have to get to, and I have to get from -2 to 40, right? So what's the difference there? Well, what's -40 minus 2? That's -42. And the common difference would just be that you would just divide those two. So that's one way to solve for D when you're given a situation like this. This is kind of like a slope idea. It's kind of like change in y. This is my change in y over change in x. So that's another way to think of it. So there's my common difference. So then once I know that that common difference is -7, I can just do, oh, well, that means this has to be -9. Oh, wait a second, I did something wrong. Oh, it's not -40. It was +40, wasn't it? Minus -2. That's why. Whoop, there it is. This should have been 40 minus a -2, so it's +42. I was like, wait a second, that common difference should have been the same as this common difference, which was 7. So yeah, +7. I caught it. So then this would have to be, right, +7. So that would have to be -9 plus 7 plus 7. And you could fill in, you know, the rest of your terms here to get your sequence. Again, you just need to list 3 or 4 terms to show the whole sequence. That's good enough. Okay, going on to the back. Let's say we wanted to find the sum of a bunch of sequences, or a bunch of numbers in a sequence, and we wanted to add them up, but we didn't want to just add them up manually. So this is a formula that's going to give us the sum of an arithmetic sequence, and there's 2 different versions. And really what the versions are, the difference between them is that this one has D, this one has A sub n. Okay, so if you have D given to you, you would use the first equation. If you have A sub n, you would use the second equation. That's really the only difference. They're just variations of each other. So for this example, let's see what we're given. We've got the first 30 terms, so that's n equals 30. And here's our sequence. So what do I know? I know that A is equal to 2, and I also can find that my common difference is 4. So I know A, I know D, and I know N. And so that means I would use the first equation. Okay, so my first equation, the sum of the first 30 is n over 2, 2 times 2, plus n minus 1 times D. Just plug everything in and then work it out. And you can use your calculators. I don't know what 29 times 4 is. Where's my answer key? Somewhere. Oh, there's calculator. Work it on your calculator. You should get 600, I think. Okay. All right. So now for the next example, let's see what we're given there. In this one, you're given that the first term is 6. So I'm given A is 6, and we're given the 40th term is 71. So I'm also given A sub 40 is 71. It wants the sum of the first 40 terms, so n is 40. So it wants S sub 40. And since I don't have d, but I do have a sub n, I have a sub 40, I'm going to use the second equation on this one. So I'll do 40 times 6 plus 71 over 2. And when you work that out in your calculator, you get 1540. And you're done. Now, that's the first part of what it asked. It asked the sum of the first 40 terms. Check. But now it wants you to find the common difference for the sequence. So you have a couple options. This is kind of like the problem we did in example 2, where you're given this information, right? So to find the common difference, I could just do that slope idea, right, where I do the difference 71 minus 6 over 40 minus 1, because that's like a sub 1. Right, so you could do it that way, and I think this reduces, what do you get, 65 over 39, and I believe that reduces. So this would be my common difference. There is another way to do it. There's always more than one way. I always have to show you lots of different ways. And that would be working backwards from this information that you just got. So if I know that the sum is 1540, I can now go back and use that first equation, right, which is n over 2 times 2 times a plus n minus 1 times d. And then I would just work backwards on this equation. It's a little longer, but it's not too bad to solve for d. So 1540 equals 20, 12 plus 39d, divide by 20, what is that, 77, subtract 12, divide by 39, what is that, 65? It should be, oops, I don't know what just happened. So then again, 65 over 39, you get the same answer. Okay, so again, like always, I have to show you multiple ways to do everything, but pick which way makes more sense for you in the problem. So really this chapter, summarize, was a bunch of formulas for arithmetic. Again, these are only for arithmetic. These only work if it's an arithmetic sequence with a common difference. All right, good luck on the practice packet, and I look forward to seeing your submissions of homework. Have a great day.